First things first, we're going to use the Myers theorem to write set 4 in the form a plus bi. Okay, so what we're going to do here is we're going to first do polar form. What do I mean by polar form? We're going to break it up into this complex numbers located in the second quadrant. Everybody agreed with that? It's root 3 across, and how high is it up? 1. What you do first is you tan inverse your 1 over root 3. Can anybody tell me what that is? I believe it to be 30 degrees. Okay, can you just verify it for me?
Yes, 30.
30 degrees. Okay. Now we all know that you don't take it from there, you take it from the start. So what angle would be in red there? 150. Okay. Next order of business is polar form is r cos theta plus I sine theta. Is that okay with you guys? We have the angle as cos 150 plus I sine 150. Okay? But can anybody in the class tell me how do you get the r value? You use Pythagoras theorem. And where did you do Pythagoras theorem again? Pythagoras theorem would be 1 squared plus root 3 squared equals r squared. 4 equals r squared. R equals 2. Is that right with you guys? So would everybody agree that's our complex number in polar form right there? Everybody cool? Now the next thing goes is use the Myers theorem to write set 4 in the form a plus b root ci, where a, b, c element z. A, b, c element z basically means that it's they're all either minus or plus numbers. You got it? Whole numbers. Now if z equals this, can anybody tell me what set 4 would be equal to? That to the power 4, would you agree with that? And that's to the power 4, because the 4 works on the 2 normally. And what does it do to the angle? So cos 600 and? Now can somebody in class tell me what cos 600 is? To the power 4 is 16. Cos is minus a half, is it? And the other one? I think it'd be minus root 3 over 2. Yeah. Multiply that by 16 and what do we get? Minus 8. Yeah. Now that's not bad for part A, no? Standard. Yeah. Now next one. I haven't seen this one before, so bear with me. Complex number w such that the modulus of w is 3 and it makes an angle of 30 degrees with the positive sense of the real axis. Okay, so what I'm saying here is that if you drew a complex number and you marked the origin, yeah, positive sense of the x-axis means it's would you agree that that's a positive angle would be this way? Is that right? So I don't know where it is. I'll call that I have no idea. Let's call it a plus bi. Is that alright? It could be it's 2 numbers I don't really know. But what else can we say? We can say that this is 30 degrees. And what can we say about the length? 3. And then in polar form it will be? Did anybody get this one out last night? 3 cos 30 plus I sine 30. And what's that in the calculator? 3 root 3 over 2. And 3 over 2 I. Now what it says is that this complex number is w. Yeah? Would everybody agree that that's w right there? And can anybody in class tell me what z is? We did it earlier, didn't we? Z is minus root 3 plus I. And t equals z multiplied by w. Is that right? So z multiplied by w. Now guys, if you're not good at multiplying surds, you don't have to be. You can just use your calculator. Now we'll figure this out. What's minus root 3 times 3 root 3? I think the root 3 hits the other root 3 to make it 3.
Minus 9.
And then it's minus 9 over 2. Root 3 times the 3 on top there. Minus 3 root 3 over 2. I. The next part's going to come in really handy then, isn't it?
Yeah.
3 root 3 over 2. I. And then the last part.
Minus
3 over 2i squared, which is?
minus 3 over 2.
The middle cancels, don't it? Doesn't it?
Yeah.
And what do we get then?
Minus 12 over 2. So
Which is?
minus a half. Oh no, sorry, minus.
Just minus 6.
Yeah.
Is that the answer? So we might have looked at the marking scheme, so I don't know for sure. Okay. So, next one. This is a root of this equation here. Now there's a hint here. Can anybody tell me what the hint is? What? Everything here is real numbers. They're real coefficients. So an example could be, it could be 2z squared plus 3z plus 4 equals 0, something like that, couldn't it? And what does that mean? Has to be the other root. The conjugate has to be the other root purely because it's real. That's it there. Minus 4 minus 3i. I'm going to take this question one step further if you don't mind. I'm going to find out what A, B and C are. It doesn't ask you to do it, but I want to do it just to show you how it's done, yeah? So here's what we're going to do.
So it's just this is conjugate.
Remember this thing here? Z squared minus the sum times Z plus the equals 0. Is that okay?
So for that, it's just the conjugate is the other.
Yeah, because all the numbers are real. It says it as, if it's element R or element Z, it means they're real. Okay. Now, what does that? It means there's no. You could have an equation like this. I would call that 3 plus 1z. Remember the ones that have the i's in front of the z's?
Yeah.
It's not one like that because it says that they're real numbers. Okay. So what we're going to do next is I'm going to do this equation. What happens when you add them together?
Minus 8.
So what's minus 8?
Plus 8z.
So that's z squared plus
8z.
8z. Now multiply them together to get the last part.
Plus 16 plus 9, so plus 25.
William's right. If they're conjugates of each other, what happens to the middle part? Alright, it does indeed. And then the end is minus 9i squared, which will be? Can anybody tell me, if I do the minus b formula on this equation here, what happens? If I do the minus b formula, what will I get out as the answer? Alright? Everybody on board with that? Okay. Ready to move on?
Yeah.
This one. Express it in its simplest form. I'm not going to multiply that out 8 times, am I? Can anybody suggest an alternate method for that?
That formula.
1 plus I is here, isn't it? 1 plus I is 1 across and 1 down. R squared equals 1 squared plus 1 squared. R squared equals R equals. Calculate the angle. Tan inverse, opposite over adjacent.
1 over.
Which is? Polar form, please.
Or root 2 cos 45 plus I sin 45.
Root 2.
For this one, you have to do that equation where you do.
One sec. Root 2 cos 45 plus I sin 45. You don't have to do any of that 2n, 360n business.
No, not
it's not a solved question.
2c thing.
What?
The other one where you only factor press c.
The binomial, no. You could do it the binomial way, but that'd take you ages.
Alright.
No point. You're not wrong, but
And
it'd take
then you just do the 8, yeah.
to the power of.
8.
Now what's root 2 to the power of 8? And then 8 times the angle, cos 360 plus I sine 360. So what's root 2 to the power of a? 16. Cos 360. 1 plus.
0.
So 16, right? Right. Next one. This is a root of this equation here. Find the other root in the form m plus ni, where m and element r. Okay. Why don't we just do the minus b formula? Okay, ready for this?
Multiply that first.
No. Would you agree any quadratic ever has been solved using the minus b formula?
Yeah.
Like, it works for everything, okay? It works for this as well. So we're going to get into trouble halfway through.
You have to long division.
You could do long division as well. We'll do it both ways, will we? Yeah, we'll do it both ways, and we'll expand our options, okay? So those of you who would have went for the minus b formula is a is 1, b, c,
3 minus 4.
I. Minus b formula. Now is everybody alright if I work out b squared and 4ac over here in the corner? Just don't want to clog up my full question. So minus 4,
Minus
4 I, and then I squared, yeah?
Minus 1.
Which is minus 1. That'll give me
4. Oh, minus 5. Minus 4.
minus 4 I, okay? Now what about 4ac? Minus 4ac, so minus 4,
Minus 4.
and then
Minus 12 plus 4.
3i, which is?
Minus 12 plus 4.
What's it, minus 12?
Plus 4.
Plus 4i,
Minus 12
minus 12,
plus 4.
plus 4i. I'm just seeing that I make a mistake. I feel like, plus 4. See that? And that's a, I just felt like I made a mistake. I was about to get root 17, and root 17 wouldn't have been that nice. What do we say is 4? 3 minus 4, right? Now, we're going to add the two of them together now, aren't we? So, what's minus b?
Plus 2 minus I.
2 minus I plus or minus the square root of?
3 minus 4 squared.
No,
Oh, sorry,
it's
yeah.
3 minus 4i,
Yeah.
and then minus 12.
Plus 4i.
But what is that then? It's just minus 9, isn't it? There we go, it's minus 9. This actually has turned out to be really easy. It's turned out as a lovely question, in fact. All over 2 times a, which is 2 times 1. Standard is actually quite low so far. So,
Marks questions.
no, this is a leaving certs question. So, what's? Can everybody tell me what's root minus 9?
Minus 9i. Or 3i.
Just 3i.
Yeah.
Just square root it as normal, and the minus turns into I. Well, we know we're on the correct path because we have to get this answer here, don't we?
Yeah.
And we have to get another answer as well. So 2 plus 3. Oh, sorry. 2. It's 2. What's minus I plus 3i? 2 plus 2i over 2. That's our 1 plus I then, isn't it? As predicted then the other way.
2 minus 2i. Is it?
2 minus 4i over 2, which is?
1 minus 2i.
There you go, there's your two answers. I feel that's a reasonable way to do that question. Now, for those of you that wanted me to do it the division way, you're not wrong. Let's see how it goes, yeah? Can I rip this off?
You don't have to, because that seems pretty easy.
Yeah, but look, it's good that if you make a wrong decision, it's good that you can follow it through and get yourself out of it.
Nothing easy, just to move on to another question. Just we cover more.
Probably should do it this way. This is covering a question in a way. Is that everybody all happy with if that's a root? Remember, if z equals 3 is a root, z minus 3 is a. Okay, and then we divide that into. Now I'm going to multiply this out now. Minus 2z's. What?
That's always meant to be a 1.
Yeah. Z minus I minus I.
Gotcha. Yeah. And then the other one?
Plus 3 minus I.
Okay. Z into Z. Z times, yeah?
Yeah.
Multiplied out.
Minus Z squared.
Minus 1Z.
Plus Z.
Minus IZ.
Plus IZ.
It will be in a second. Change sign. Remember the DMS drop. Divide, multiply, subtract, drop, yeah? So what do we get now? Minus
Z.
Z. Yeah.
Plus 2I 2Z.
Sorry?
Plus 2I Z.
Plus 2I.
Z.
Z.
Plus 3.
Just plus the 3. Okay.
Minus 1.
Minus 1, yeah? Is it?
Yeah, it is. Yeah. Z into minus Z minus 1.
What's the answer we got last time?
1 minus 2i.
Was it 1 minus 2I?
Yeah.
Perfect, right, so we're still on board. It should be minus 1. You said 1 minus 2I is the answer we got, yeah? So I'm expecting a minus 1 plus a 2I up here if I get this correct, alright? Multiply by minus Z. Minus Z. Then
Plus 1.
plus 1. And then what's under here then?
Why'd you put plus 1 over that? So
Because it's compatible with the 3. And then that's going to be plus I. Would you agree with that?
yeah.
I'm putting that under there as well. You'll see in a second. Reverse the signs. Plus.
Minus minus.
Now that cancels. This one goes in unaffected. There's nothing to take away from it. And then underneath we're going to have 2 plus. Is that right? 2 plus I?
No, oh no, it's
Yeah.
2 minus I. 2I.
Well,
2 minus 2I, isn't it?
3 minus 1, 2. Oh yeah, 2 minus I, you're correct.
2I.
2 minus I.
Look at the minus I up there.
Yeah, here. Alright. Now I'm going to take this one down as well. Oh, sorry, and that
Yeah.
gives you 2 minus
Yeah.
2i, sorry.
Yeah.
Now guys, what's next? How many times does Z go into 2IZ? Plus 2I. Multiply it out, and you get 2IZ. 2I times minus 1.
Minus 2I.
Minus 2I. 2I times minus I.
Plus 2.
What?
Plus 2. Oh no, minus
Yeah,
2.
no, you're right, with the plus 2.
Yeah.
Then what happens when I subtract everything? Now, I would say it does work, but I'd say that's a shade more difficult than the minus b formula. Is that okay? Good practice though. We've done. Now, lads, would everybody agree? If I said, I need to make up a fraction here, let's say 3/10. If I said 3/10 is the same as 1 over 5 plus 1 over 10. Would everybody agree with that?
Yeah.
What happens if we turn it upside down? Is 10 over 3 the same thing as 5 over 1 plus 10 over 1?
No. Oh, is it?
It's not.
Oh, it's not.
You can only turn stuff upside down when they have the same denominator. Okay, and you actually have to add them together and simplify as well. So in order for this trick to work, it has to be 3 over 10, let's say, equals 6 over. Would everybody agree? 3 over 10 equals 6 over 20. Would everybody agree with that? Would then everybody agree that 10 over 3 equals 20 over 6? It is, yeah. 3 1/3. Okay. They need to be broken down into one fraction and one denominator on each side. Okay.
Can't be adding.
Can't be adding, right? So I bring you the solution to the question. It's asking me to find Z1 on its own. Do you get that? Now, first of all, what's the common denominator between all these?
So 3.
Why don't we just look to the right? What does it not have?
Is that 2?
And
3.
so that's Z2 by.
So 3.
Okay, what about the other side?
So 1, so 3.
The next one?
Z2, Z1.
That's right. Everybody right with that? What can I do with the common denominators? They can bugger off, can't they? Now what do I have left then? 2 times Z2, Z3 equals
Z1, Z3.
Z1, Z3 and
Z1, Z2.
Z2,
Z1.
Z1. Now I'm going to factorise out Z1. So I'm left with Z3 plus Z2. Is that okay with you guys? Now look what I can do next. Everybody ready for this? Here's what I'm going to do. I'm going to do Z2 multiplied by Z3. What is Z2 multiplied by Z3? 2 plus 3i and 3 minus, multiplied out, 6 minus 4i plus 9i minus 6i squared, which is,
Plus 6.
what do we get? 12. 12 plus 5i. Everybody right with that? Multiply that by 2. And you get?
24 plus
Okay, great. Everybody happy enough with that? I just multiplied Z2 by Z3. See Z2 and Z3 on top of the board? Yeah? I just multiplied them by each other and then I multiplied the answer by 2.
2. Yeah.
Okay. Now, next thing I want to do is what is Z2 plus Z3?
2 plus 3i plus 3 minus 2i.
2 plus 3i plus 3 minus,
2i.
and what does that turn into?
5 plus I.
5 plus I. Z1 multiplied by 5 plus I is the same thing as 24 plus 10i.
Bring that under.
Bring it under. And would everybody agree that Z1 equals that?
Yeah.
What do I do to get rid of the denominator?
Conjugate.
Top and bottom, yeah? Then what you get next?
Get a
120
Yeah.
plus 50i
Minus 24i.
minus 24i
Plus 10.
plus 10. Okay. And then on the bottom, I reckon we're going to have some sort of 26s, are we?
Yeah. 25.
5 by 5.
25.
Minus I squared, but minus I squared is plus 1. The middles cancel. So I'm going to have 130 plus 26i all over,
26.
which is 5 plus I. We good?
That's pretty good.
I am going to speed ahead because you can always look at this later. I should probably get as much done as I can, right?
So recording.
Yeah. Okay, ready? Now. Yeah. 1 sec. Now, the next one. Remember what I told you about cubic equations? Okay? They usually cross 3 times, don't they? You'd have 3 real roots, wouldn't you? You'd have z equals, let's say, minus 3, z equals 2, and z equals, let's call it 4. Is that alright with you guys? What can you tell me about when they have complex answers? They usually only cross once, don't they? So you have 1 real root and 2, the other 2 are going to be conjugate pairs. How do I know they're going to be conjugate pairs? 1 real, 2 conjugate pairs. And will you tell me why? All the numbers are what, guys?
Real.
If they're all real, you either have 3 real roots or 1 real and 2 conjugate pairs. This question is in the complex numbers part of the course, so what's your guess on what roots we're going to be getting?
Complex.
Complex, right? Can everybody class take out your table? Next step, we're all going to take out our calculator, and what we're going to do is we're going to enter this into the calculator. Mode, table function. You're going to use x instead of z. See the last number's 15, don't you? So it's going to be somewhere in the 15 region, like 0 to 15 somewhere. Now what we're going to do is we're going to start off from minus 10 to plus 10. Is that alright? And hopefully we'll hit the answer. We're looking for when the y value is 0, because that's where it crosses the axis. Keep going.
Just step with point 1.15, sorry.
You want to try a step at 0.5? Higo's suggesting that it could be somewhere in between 1 and 2. Would you agree with that? Let's try a step at 0.5. Okay? And start at 0,
Go to 3.
end at 10, step at 0.5. Let's see if that helps at all.
Oh.
1.5 and?
0, 0.
Now, that is particularly min. Okay? Everybody get that? That is particularly min. So here's what we're going to do. Okay? Z equals 1.5. Now, Higo knew to do that because he was looking at where it crosses the axis, and when you go up in steps of 1, I'll show you how Higo figured this out. See the way it has to cross the axis. See the way it's still negative, but crosses the axis in between 1 and 2. It goes from below the axis to above the axis. Higo knew it had to happen in between 1 and 2. That's why he decided to go up in 0.5s to see if he got any closer, which he did. Now here's how you show this happens, guys. You substitute 1.5 into the equation. Now you work this out separately if you don't mind me saying. Okay. Is everybody capable of showing all the numbers and showing that equals 0? It will equal 0, by the way, just let you know. But just write down all the workings. Okay? Now, if Z equals 3 over 2, would everybody agree Z equals 3 over 2? 1.5. What's the factor then? 2Z equals 3. 2Z minus 3 equals 0. Is that okay with you guys? Now, what's the next step after this? Now, I won't be finishing this question, but what's the next step after it? You get this here, and what happens? 2Z cubed minus plus.
What 2Z minus 3?
Okay. What's going to happen up here is you're going to get a quadratic. I'm just going to make up a quadratic for you, just for argument's sake. That's not the right answer now. But what you're going to do with this answer? Use the minus b formula, and you'll get all 3 roots. Is that okay with you guys?
Yeah.
The hard part was the 3 over 2, putting it into its factor, and then dividing it in. Is that right, Dave? Okay, I'll go to the, not that one, this one. This is the one I want, okay? Everybody ready? Now, as discussed previously, radians are the devil, okay? So what am I going to change pi into? 180. What's 180 divided by 9? 20. 20 multiplied by 4? 80. I'll take that. Okay? Next step. What's 5 and 1/16? You'll find it's 81 over 16. Is that okay with you guys? Let's polar form this. What happens when I polar form this, guys?
81 over 16.
After that?
Cos 80 plus 100. Get to.
Is that okay? Now you notice I'm giving it a wide berth. Okay? I'll explain why. It wants me to do W4 equals Z. Would everybody agree that this here is Z? It wants to know what number, when I multiply it by itself 4 times, will give me Z. Essentially, this is a solve question with how many values of W at the end?
4.
W4, W3, W2 and W1. When it's a solve question, what's the adjustment I have to make? It's a solve question. Alright? You alright, Ken?
Yeah, on the first part of it, do you not have to multiply 180 by 4 because it's 4 or 5?
Oh, it is. Yeah, I did that. It's 720 divided by 9, which is 80. Yeah?
Yeah.
Now, guys, we're going to save ourselves a bit of time here. Would everybody agree that this thing here is Z? Yeah? And since we're agreeing that that's Z, I'm just going to drag it more central. Would everybody then agree that W4 is meant to be equal to Z? Yeah? And what happens when I bring the 4 over the other side? Remember we said x4 equals 16. What could I say x equals? 16 to the power of? A quarter. So what am I going to do here? Whole thing to the power of a quarter, yeah? Is that okay with you guys? Now what is 81 over 16 to the power of a quarter? Donnelly has it as 3 over 2. What you do with the quarter and the angle? Multiply. What's 80 divided by a quarter? 20 degrees, yeah? What's 360 divided by a quarter?
90.
Okay, and then the other one will be exactly the same, won't it? Now, can anyone in class now tell me, is everybody happy with 81 over 16 to the power of a quarter? I'll just change that to 3 over 2. Yeah? Now, what do I do to find W1? N equals 0, N equals 1, N equals 2, N equals?
3.
Okay, so what's the first one?
3 over 2 cos
20 plus?
20.
Does it want me to leave it in polar form?
No, A plus BY.
In polar form.
I want to.
So, does everybody agree that I don't have to multiply that out? Because I want it in polar form. If I wanted it in rectangular form, what would you do? You'd multiply it out. What's the next one then? 3 over 2. What next, guys? Cos?
110.
Plus? Next step after that?
3 over 2 cos 200.
Yeah. Plus?
Sin 200.
Good job. And finally? 3 over 2 cos?
290.
Plus? Okay, guys. Now,